In our next section, we're going to continue the discussion of the ASA transparent firewall and look at the ARP filtering features that it supports for the ARP inspection, where we talked about the different types of traffic that the transparent firewall allows, which is going to be your normal inspected traffic like TCP and UDP, and then the exceptions based on a specific format of layer 2 MAC addresses like the broadcast or multicast, the spanning tree, and then also the address resolution protocol. So with the transparent firewall, ARP is allowed by default, both from the inside out and the outside in. Now, the disadvantage of allowing this is that it potentially allows the segment to be open to an attack that is for ARP spoofing. That if someone is sending gratuitous ARPs to try to poison the ARP cache, and the ASA is allowing these through from the outside in, then there's no way that it can control that. So the ASA supports something that is known as ARP inspection. This is kind of similar to how the dynamic ARP inspection feature works in the catalyst switches, but the difference is it doesn't combine with DHCP snooping. So it's going to be a standalone manual configuration that we need to do, and it's going to be matched against the static ARPs that we are manually defining. So if it matches the static ARP and it's the wrong address, then we're going to drop the packet. If it doesn't match it, we can define, do we want to drop the ARP or are we going to forward the ARP? Now, from a configuration point of view, it's a very straightforward config. We just specify what's the static binding that we want to define. So on the inside interface, the host 1234 has this corresponding MAC address, 1234567, etc. Then we specify if there is not a match in the static ARP, what do we want to do? Do we want to flood the ARP request or do we not want to flood it? Okay, the default is that the ASA does flood the ARPs both from inside out and outside in when we are doing transparent mode. Now the same is true with MAC address learning, that in transparent mode, the ASA is going to behave like a normal layer 2 switch. Then it's going to learn MAC addresses based on the flooding of traffic as it comes from the inside to go out and it comes from the outside to go in. Now, MAC learning can be disabled, and we can replace this with static MAC address entries. This is going to stop anyone else on the segment that we don't want to send traffic from being able to forward through the link. So for example, if we know that there's only one device on the inside and one device on the outside, we could just configure a manual binding for their static MAC addresses and then disable MAC address learning on the inside or the outside. So it's technically a separate feature from the ARP inspection, but they work the same way, that we're trying to secure based on the layer 2 MAC addresses, either the IP to MAC address mapping, which is going to be for ARP, and then the actual data plane, which is going to be with the MAC learning. So you could loosely correlate these features to the dynamic ARP inspection and the IP source guard features in the catalyst switch, but the main difference is that we do not have a dynamic DHCP snooping database. So for the ARP configuration, we would have to configure these as manual bindings, and then the same is true for the MAC addresses. If we want to permit or deny a specific MAC address, we would need to manually define that. So let's look at this within our particular configuration now, where we have two different segments that we're bridging together. We're bridging VLAN 30 and 40 together, and then bridging VLANs 50 and 60 together. So let's go to router 3, who is on the inside interface of the firewall, and let's debug IP ARP. Or actually, it's just debug ARP. Okay, then on router 4, who's on the outside, let's clear the ARP cache. We should see router 3 receive the ARP request now from router 4. Router 4 is trying to refresh its cache. It's saying, this is my MAC address. This is basically the gratuitous ARP. This was a reply. Then it's getting an ARP request saying, I'm trying to refresh the entry for 34.3. Router 3 says, 34.3, that's me. So I'm going to reply back and saying, this is my particular MAC address. But notice here that the gratuitous ARP reply came from the outside interface of the ASA and then was allowed inbound. So it was the reply for itself and then also the request for the address 34.3, which router 3 has configured on the link. So this is the default behavior of the transparent firewall. Now we cannot filter this with a regular access list because a regular access list is just for matching IP traffic. And IP ARP, it uses a separate layer 2 protocol type code, which is ether type 806 as opposed to ether type 800, which is for regular IP version 4. So if we do not want to allow the ARP through, then we need to do this with the manual ARP inspection. We cannot do it with an access list. Okay, so on the ASA, let's look at the show ARP. And right now, it doesn't have any resolution. So let's go to router 3, and let's see if we can ping the ASA's management interface. 136.134.17. And then the same from the outside. Ping 136.134.17. Okay, we can see you can ping the ASA itself, just like we can in the routed firewall. If we look at the ARP cache, now we know who is the resolution for router 3, who is the resolution for router 4. Now to configure these manually, we would say in global config, on the inside interface, actually inside 1 there, what is the resolution for this IP address to its MAC address? We could then specify when we do ARP inspection on inside 1, do we want to enable the flooding of ARP requests, yes or no? So let's say let's enable it, but let's also flood requests. Okay, the same on the outside. So the link to router 3 there is inside 1, the link to router 4 is outside 1. Okay, next on router 3, we're still debugging IP ARP. Let's go to router 4 and clear the ARP cache again. We can see router 3 gets the request and the reply from router 4. So there's the gratuitous ARP, and then there's the actual request. If we were to say on the ASA that we will enable it, but we will not allow flooding, so on the inside and the outside interface, we're not going to flood the unknown requests, we would see now when router 4 clears the ARP cache again, that the ASA is going to drop this. So if we turn logging on, logging console 7 and logging is on, then let's clear the ARP cache again. The ASA should tell us ARP inspection is on and we failed to check for ARP responses received from this host on the outside. The host is advertising a MAC address for the IP address 34.4, which is dynamically bound to that address, which is fine. It's technically a valid resolution, but it's saying that since we have inspection on and we didn't statically bind this, it's not going to allow it. So if we show run ARP, or let's just say show run include ARP, this is doing the static binding, and then this is saying do not flood any requests or replies other than that match this manual mapping. So in order to get this to work, we would have to say on outside 1, we have a mapping from this layer 3 address to this layer 2 address. If we clear the ARP cache on router 4 again, we see that we get the reply from 3 to 4. Okay, if we clear it in the reverse direction, we can see we're getting a reply from router 4. So we're asking them who has this particular MAC address. Is it still this one? Router 4 is responding and says, yes, my MAC address has not changed. So when we look at the ARP cache of the routers on the inside and the outside, we should see that all of these entries are completed, okay, that they do have layer 3 to layer 2 bindings. Again, if we were to remove that last statement, which is the static mapping, okay, so we no longer have a static mapping for 4, when we clear the ARP cache, then show ARP, ARP inspection check failed for the response. Let's try that again. Actually, there it is. So right now, router 3 does not have an entry anymore for router 4. So as it stands, they would not be able to exchange traffic over the transparent firewall. So again, this is only within the scope of transparent. When you're doing routed, the ASA would be the ARP destination. It's not going to be bridging the ARP request between the multiple interfaces. And again, as opposed to the Catalyst switch, Catalyst can populate the ARP database based on the DHCP snooping database. Because when the end host requests an IP address, it's inside the DHCP discovery message. It has the MAC address already included there. So the layers 2 switch would be able to correlate. This is the port, this is the IP address, and this is the MAC address. And then not only does the ARP need to conform to that, but also the actual data plane, which would be the IP source card. But here in the case of the ASA, we're simply doing this manually by putting the binding of this particular IP address corresponds to this MAC address on that individual interface. Okay, the other one again is the MAC learning. If we say MAC address table static, and then what is the particular interface? So on inside 1, we know of some particular MAC address. Let's say router 3's MAC, which is this one. And then MAC learning, do we want to, on inside 1, disable MAC address learning? Okay, what this would prevent is someone in the actual data plane. So let's do this. Let's show run include ARP, and let's remove the dynamic ARP inspection. Let's clear configure ARP and clear configure ARP dash inspection. Show run include ARP. Okay, we can see those are deleted. So now 3 and 4 should be able to reach each other. So 3 telnets to 4. And let's see, 3 may need to send the request again. Let's ping 136.1.34.4. And I may actually need to flap the interfaces now. Let's say interface inside 1, which is gig 01.30 and 40. Let's shut those down. And then re-enable them. So the entry is still getting filtered. It looks like it didn't, even though the commands are not there, it didn't disable the inspection. Let's show run ARP, which is not there. Let me actually add the commands back in, and let's say that we want to do the flooding. So let's say on outside 1, enable flooding, and then on inside 1, enable flooding. So this should already be the default, but for some reason in this particular case, turning it on and then turning it off didn't work. Okay, there we go. So we can see the ping is being dropped, but at least they were able to resolve each other. So now let's telnet from 3 to 4. Okay, so we can see now they have connectivity to each other again. Okay, next we're going to configure the static bindings for the MAC addresses. So on the ASA, if we look at the, and let's turn logging off for a second, no logging on. Let's say show MAC address table for group 1. That's our particular bridge group. Now we're going to do the MAC address table static entries on inside of 1. This is the MAC address of router 3. On outside 1, this is the MAC address of router 4. And we're going to say that MAC learning on inside 1 is disabled, as well as outside 1. Now, since the ASA has the static bindings for them, when we look at the show MAC address table, you notice that these types are now static. Previously, they were dynamically being learned. So router 3, it should still be able to send a flow through the ASA, which it can. The difference is going to be is that if I now go to router 3's interface and change the MAC address, so this would be like someone trying to spoof router 3's MAC address, the ASA is no longer going to learn the new advertisement, and now it's going to start to drop the flow. And I'm not sure if the logging is going to actually show us this. Let's turn logging back on. Logging on. And let's give router 3 another new MAC address. Let's say the MAC address is 0033. Says it received an ARP response collision. Let's do this. Let's try changing its IP address too then. IP address 136.134.33 with MAC address 00133. So it looks like in this case it's simply silently dropping it as opposed to generating a log message, because it's basically happening in the layer 2 CAM table before it gets to the inspection engine. So you could theoretically do the same thing on the catalyst switch by doing the static MAC address entries and then filtering out, like you could filter out ARP at layer 2 with a VLAN access list. And then the end host would have to do static mappings for their ARP entries. We will talk about this when we get into more details with layer 2 security and what are kind of the equivalent functionalities between the iOS in transparent bridging, the ASA in transparent bridging, and then the catalyst switches, which are doing the normal layer 2 switching. So you can see there are technically two unrelated features here, the MAC learning that you can filter, and then to prevent the ARP spoofing. But they're worth mentioning now because, again, these only apply when we are doing the transparent firewall. Because at the routed firewall, we're routing the traffic. We're not trying to bridge the ARPs, or we're not trying to learn the MAC addresses from the bridge groups.